Number 11, f of x equal to 16 to the power of x. And they ask you to find those three following things. The first one is f of 0. When x equal to 0, your function becomes 16 to the power of 0. And you know that anything to the power of 0 will be 1. So this one has the answer of 1. That's part A. Part B, when x equal to negative 1, that will become 16 to the power of negative 1. And we don't really like negative powers. And you may recall that anything with a negative power, if you want to change it to the positive power, it will become the reciprocal of that. So x to the negative n power will become 1 over x to the power of n. So this one will become 1 over 16 to the power of positive 1. And 16 to the power of 1 will become just 16. So for B, the answer is 1 over 16. And for C, when x equal to a half, your function will become 16 to the power of a half. And we don't really like this power of a half. Then we can use this formula here. X to the power of 1 over n will become the nth root of x. So here, power of 1 over 2 will become the second root of 16. And usually if it's 2 here, we don't really write it. So it's a square root of 16. Square root of 16 is just a 4. So that's part C. Number 12, they ask you to simplify the following. So let's look at them one by one. For the first one, if we look at the what's inside the bracket here, we first want to simplify that if possible. So we can see that there are a to the power of 5, a to the power of 3 up and down here. So we may simplify this first. How to do that? We know that the quotient of the exponential expression with the same base, we can use a new power. The power should be the subtraction of the previous two powers. So for this one here, the a should have the power of 5 minus 3, which is 2. So with all the rest remain the same, your expression will become 5 times a squared over b to the power of 4. And this is much simpler compared to the original one. And this one will raise to the power of negative 1. Then the next step, we want to deal with this negative 1. We don't really like the power outside. So what we are using are those two. So if we have some product squared or the quotient squared, to the raised to some power n, we can give power to each of them. So this one will become, we can give negative 1 to each one of those 3 terms. And then the next, we don't really like something raised to the power and then raised to another power. So we want to deal with that. What we are using is this formula here. So x raised to power n, then raised to power m, will become x raised to the power of n times m. So if we use that, this a power will become 2 times negative 1, which is negative 2. And for the b, we use very similar strategy. Its power will be 4 times negative 1, which is negative 4. And for 5 to the power of negative 1, we just keep that the same here. The next step, we don't like negative powers. Then how to deal with that? I think we already talked about that in the previous question. We use this formula again to change the negative power to the positive power. So everything changed to the reciprocal of that itself. So this 5 to the negative power of 1 will become 1 over 5 to the power of 1. So it will come down. Same thing to the a to the power of negative 2. So it go down. A will have the power of 2. And the b of the power of negative 4, it will flip to the upper part. So, the numerator. So b to the power of 4. So this result should be your final result here. Part B, we'll use very similar strategy. First, simplify what's inside the bracket. Here, you can see that the coefficient for the numerator and the denominator, they also are pretty big. So you really want to see whether you can simplify that or not. What we do is first factorize those two coefficients. So 18 will become 2 times 3 squares. We will use only prime numbers. For down here, 9 will become 3 squares. So the next step, again, we want to simplify that. So we know that for the power, for the same base, the power we do the subtraction. So 2 will remain the same. 3, the power should be 2 minus 2. So we put that here. For the m, it's 2 minus negative 4. We put it here. And n have the power of negative 2 minus negative 5. And again, we put it here for further simplification. And again, we can further simplify that. So for the 3, the power is 0. 2 minus 2 is 0. And for m, 2 minus negative 4 is 2 plus 4. For n, minus 2 minus negative 5 will become minus 2 plus 5. And we can further simplify that, which is much easier. The 3 to the power something term is gone because anything to the power of 0 is just a 1. So now, what's in the bracket is simplified. What's next is to deal with this negative 3 power. We want to give it to each of those terms inside your bracket. So you give the negative 3 power to each one of them. And we don't really like this term here and this term because they have 2 powers. So what we do is multiply those 2 powers. This is the next step. So 2 to the power of negative 3, we just copy that. For the m, 6 times negative 3 is negative 18. So we put it here. N has a power of 3 times negative 3, which is minus 9. So this finishes dealing with this power outside. Then we don't really like negative powers. So what we do is we want to change it to positive power by making the whole term the reciprocal. So for the 2, it has a negative 3 power, so it's going down here and change to the positive power. Same thing for m and n term here. And we know that 2 to the power of 3 is 8. So we can put 8 for the coefficient of the denominator. And that should be your final answer. That's part B. For part C, it's very complicated. But if you look at the power is 0. So we know that anything raised to the power of 0 should be 1. So you know that the answer should be 1. And I'm too lazy to put this gigantic term inside the bracket. Number 13, logarithm function. Part A. What is the g of 36? G is the log base 6 of x. So log base 6 of 36. How to deal with that? We want to look at the logarithm function. Logarithm function really will give you the power of the exponential expression. So here, what we think is we use 6 as a base, because here the base is 6. And we want to know what power should we use in order to get 36, which is the number inside your logarithm function. Okay, we put the base here, and we put the number for your exponential expression result, and we want to know the power. And we know that 6 times 6 will be 16. So that means the power put here should be 2. So your answer for this logarithm function will be 2. That's part A. Part B, we use very similar strategy. When x equal to 6, log base 6 of 6. So we know that this 6 down here is the base, and this 6 here on the right will be your exponential expression result. So 6 raised to what power will be 6? We want to know this power and put that as your final result. We know that 6 is just 6, so the power should be 1. So that's part B. Part C, and we have part C and D here. It's about G inverse. So inverse function of logarithm function. What's the inverse function for that? It should be the exponential function with the same base. So G inverse of x will be 6, which is the base raised to the power of x. We know that the following should be easier. So first, for this function, plug in x equal to 0. So that will become 6 to the power of 0, which is just 1. For part D, we plug in x equal to -1. So 6 to the power of -1. And again, we don't like negative power. So it will be 1 over the 6 to the power of 1, which is just 6. So that's part D.